So the team name is Vishan Parinayak. About the robot. So this project we have tried to advance the remote control robot grass cutter with the remote vision using Raspberry Pi. The project advanced the remote control robotic grass cutter with the remote vision using Raspberry Pi. It is focused on the robot control of a rover grass cutter with an obstacle detection system. It is objective of the robot. It is portable device. It can be controlled using the Bluetooth app. It has the camera installed for the vision of the field. It has an ultrasonic sensor to avoid the obstacle. The range is from which it can avoid the obstacle is 35. It turns left from the 5 seconds when an obstacle is detected or altered. It also has two 6-volt battery connected in the series to supply the 12-volt supply to the motor driver. The bulk converter is also used to convert the 12-volt supply to the 5-volt supply to operate the Pi. The resistance is also used in order to reduce the speed of the grass cutter motor as it was taking 4, which was very large. Actual hardware photo, grass cutter video, and then the obstacle avoider. So basically uh, we have to aim and we have focus on that. So first of all we shoot the video for grass cutter and then we shoot the video for the obstacle avoidance. This is the block diagram. The various component that we have used Raspberry Pi using use web camera L298 H bridge UNL 28 relay bulk converter ultrasonic sensor. Ultrasonic sensor. The ultrasonic sensor SR04 is a sensor that can measure the distance. It usually use 40,000 hertz, which travel through the air. An object or the obstacle in the path will bounce back to the module. Considering the traveling time and the speed of the sound, you can calculate the distance. Then the configurations. Uh, then calculation of the distance uh, calculation of that distance if the object is 20 centimeter away from the sensor and the speed of the sound is 340 milli per second, zero point centimeter. The sound wave will need to travel about 588 microsecond, but what you will get from the echo pin will be the double that the number, because the sound wave need to travel forward and bounce back. In order to get the distance, we need to multiply the receive travel time value from the echo pin 0.034 and divided by the 2. Then we talk about the motor driver. L298 is a dual chain H bridge motor driver capable of driving the 2x DC motor, making it ideal for building robot two-wheel robot. The power supply from V and pin the H bridge get the supply from the driver motor, which can be used to 5 to 35 V is used for the driving the logical circuit, which can be 5 to 7 volt, and the both the same common ground name GND, and the in 1 and in 2 pin control the direction of the motor A, while in 3 and in 4 control the direction of the motor B. This is the photo of this is the L298H bridge motor. Now we come up with the setup Raspberry Pi with the camera. One very hardly tool available when we use the Pi in the option to issue the command to the Pi in what is known as a handless setup. By using a secure shell or the SSH, you can control the Pi remote from a computer. With this method, all you need to edit your Pi to a power source to keep it on. No more monitor, and the keyboard selling into the Raspberry Pi is easy and very useful as a process, allow you to issue command to your Pi from any computer with nothing more than a Wi-Fi connection. So this is the setup. We come on the why we picked the motion. When we first working on this project, we consider the separate different resources. Firstly, we consider using the PiCam, which is a camera unit building a specifically for Raspberry Pi. But the PiCam is certainly a capable device and has many applications, but it is is limited to use the programs that are specifically designed for it, is relatively expensive compared to the cheaper multi-purpose webcams. So in this order to make the program accessible for the larger audience, we decided to use the common USB webcam. The next issue was which software to incorporate. We initially considered OpenCV, which is a free software that allow for many different sort of the computer vision and imaging the project. So we found that for our specifying project, motion was simple to set up and get working, but much more robust it is exclusion. Thank you.